The area of a triangle can be found using the coordinate geometry area formula. This formula requires one of the vertices of the triangle to be the origin, 0, 0. If this is not the case, then the triangle must undergo a transformation called a translation. One of the vertices is chosen to undergo a translation to the origin, and the other two vertices will then undergo the same translation operation. The translation moves the triangle by a given amount, but does not affect its size or area. The new vertices, not the origin, are substituted directly into the formula as labelled. Another method of finding the area of a triangle is to use the geometry area formula. If the length of one side of the triangle is known, then this will be the chosen base for the formula. The perpendicular height from this base to the opposite vertex, also known as the altitude, is needed for the formula. The area of straight-sided shapes can be found by dividing the shape into triangles and using the area formula. The area of a quadrilateral can be found by dividing the shape into two triangles at the vertices and finding the area of each triangle. The sum of the areas will be the total area of the quadrilateral. The area of a parallelogram can be found by using a diagonal, which divides the parallelogram into two congruent triangles. The area of one triangle can be found using the area formula, and the area of the parallelogram is this area multiplied by 2. A regular polygon can be split into equally sized triangles. If the vertices of one triangle in the shape is known, then this area can be found and then multiplied by the number of sides in the polygon. From Euclidean geometry, we can find the area of the given triangle by finding the area of the rectangle formed by the vertices and subtracting the sum of the areas of the right-angled triangles A, B, and C. The geometry formula for the area of a rectangle is length by width. In our diagram, the length is the value of x1 and the width is the value of y2. The areas of the right-angled triangles can be found using the geometry formula. In triangle A, the base length is the value of x2 and the perpendicular height is the value of y2. In triangle B, the base length is the value of x1 minus x2 and the perpendicular height is the value of y2 minus y1. In triangle C, the base is the value of x1 and the perpendicular height is the value of y1. We can now substitute these values into our area of the triangle equation. To simplify, we will take the half out as a highest common factor. This will enable us to simplify within the brackets and tidy up our equation by combining like terms. With our simplified equation, we will now multiply out the brackets and further simplify. To tidy up, we will take the half out as a common factor again, which gives us the coordinate geometry area of a triangle formula. The brackets used in this formula are absolute brackets, which ensures that a positive area value is obtained. In our first practice question, we must find the area of the triangle ABC, given the coordinates of the vertices. We will use the coordinate geometry area of triangle formula. We must first translate one of the points to the origin 0, 0. The translation of the point A to 0, 0 needs an operation of -2 minus 4. We will use the same operation on point B and point C. We can now substitute the image points B and C into the area formula. Tidying up gives us a value of -44 in the absolute brackets, which we will change to +44 and remove the absolute brackets. Simplifying gives us an area of 22 units squared. In this question, we must find the area of the triangle ABC in the diagram, and we are given the coordinates of the vertices. We could use the coordinate geometry area of triangle formula, but looking at the diagram, we can see that one side of the triangle is parallel with the x-axis. Therefore, we could also use the geometry area of triangle formula. We will practice the geometry formula here. Choosing the side of the triangle that is parallel to the x-axis as the base, we can read its length directly from the axis. The base is 7 minus 1, which is 6. The perpendicular height in the triangle is parallel to the y-axis, so we can also read its length directly from the axis. The perpendicular height is 4 minus 1, which is 3. Substituting these values into the area formula and simplifying gives us an area of 9 units squared. In this question, we are given the area of a triangle as 22 units squared. We are also given the coordinates of the 3 vertices, but one of our coordinates contains an unknown k value, and we are asked to find the possible values of k. In this type of question, we will use the converse of the area formula. We will start by moving point A to the origin with a translation operation of -2 minus 4. We will use the same operation on point B and C. We can now substitute everything into the formula as required. We can simplify and tidy up inside the absolute brackets. The denominator of 2 on the right-hand side of the equation can be brought over the equal sign and multiplied. To solve this equation with a variable inside the absolute brackets, we go about removing the brackets by adding a plus-minus sign to the other side. We must now separate this equation into a plus version and a minus version. Each equation can now be simplified and then solved for k. We are now ready to practice on some past exam questions. When a question appears, please do pause the video and attempt the question. On resuming the video, you will see the answer fully worked and explained. In this question, we are given the vertices of the rectangle ABCD, and we must find the area of the rectangle. One method is to split the rectangle into 2 equal triangles, and then find the area of one of the triangles and double it. Another method is to find the area of the rectangle directly, using the geometry formula length by width. We will start by finding the lengths of the line segments AD and AB, using the distance formula. Labelling our points A and D, we can substitute them directly into the formula as labelled. Then, labelling our points A and B, we can also substitute them directly into the formula as labelled. Simplifying, we get the length AD as square root 5 and the length AB as square root 20. Multiplying these values gives us the area of the rectangle as 10 units squared. Here we are given a diagram showing two intersecting lines. We are also given the coordinates of the points P, Q and R and must find the area of the triangle formed by the points. For this, we will use the area formula. We will move the point P to the origin by the translation -4 - 2. We will now move the point Q and R with the same translation. We can substitute the new points directly into the formula. Simplifying and removing the absolute brackets gives us an area of 21 units squared. In this question, we are given the coordinates of the points A, B and C, which are the vertices of a triangle. We must find the area of the triangle. To do this, we will use the area formula. We will move the point A to the origin by the translation -4 - 6. We will now move the point B and C with the same translation. We can substitute the new points directly into the formula. Simplifying and removing the absolute brackets gives us an area of 30 units squared.